5-2. Composition of functions. Instead of operations with functions, it's compositions of functions. This is a special operation. Compositions are, okay? Don't worry, titles on the next page also. All right. Now, the model is a good model. And I'll explain that in a little bit, but the main thing you need out of this page is right there, that formula, okay? Now, let's talk a couple different things first before we go really in detail. I want everybody to look real close, okay? Real close. Is that circle open or closed?
Open.
Open. It's not multiplication. This is not multiplication. Multiplication, the circle would be closed. Okay, so that's also kind of going off of yesterday with notation stuff. Okay? Now, the other thing, this is not a 0 or an O. What is that? Like, best thing you know that is as a degree sign. Okay? That's basically what I explain it as. Alright? It's basically a degree sign. Okay? And the way you say this is not fog of X. Disclaimer. To make it make sense, I'll probably be saying fog of X. But that's not technically correct. Technical correct way to say it is f of g of x. Okay? F of g of x. Just like yesterday. Here's the notation you'll chances are be given. Here is the notation that will make the most sense. Okay? You just basically replace the degree sign with a parenthesis, and then you put an extra set of parentheses on the other side. Okay? Your best help, your best bet for this lesson is these two words. Inside out. Okay? You work these problems inside out. Okay, that's how this works. Alright? Now, I don't want to super go in details about the model because it can be confusing. Here's what I do want to point out to it. What is your domain or what? Your x values. What is your range? Y values. Okay, now when you go to function notation, we got to change the question here. Your x is your domain. What's your range when you talk about function notation? It's not y anymore. What is it? G of what?
X.
G of x. Good. Okay, it's g of x, it's f of x, it's whichever function you're talking about, right? It's either x, and then for your x's, x is always x, that doesn't change. But instead of y, you either say f of x or g of x, depending on which function letter you're working with, right? F, G, H, whatever it may be. Okay? So, if you look at the model just briefly, you start in the domain of g, which would be the g's what? The g's x's. Then you move over to the range of g, which is g of x, but at the same time you're in the domain of f, which would be f's what? No, domain of f would be f's.
F of G.
Range.
Close. Domain is x, so the range of g is also in the domain of x. So those two overlap. Your g's, y's, and your f's, x's overlap. Okay? That's how this all works. Once again, not to get too confusing of the model, but here's how it goes. Okay? I'm going to skip around. Hold on. I don't want to do this first. I want to do this first. Okay? Okay? F of g of x. For each pair of functions, find each composition if they exist. Okay, so F, you have 1, 8, 0, 13, 15, 11, 14, 9. For G, you have the points 8, 15, 5, 1, 10, 14, 9, 0. Okay? Now, this you used to see a question like this. And all it would say is find the domain, find the range. Okay? Domain are your what? X values, range are your y values for each individual function. Right? F has its own domain and range. G has its own domain and range. Everybody good there so far? Old stuff, chapter 1, 2, something like that. Okay? Now, what you're going to do for a question like this is this. Change this from, instead of saying fog, to f of g of x. Okay? You work these problems inside out, so you work with g first. And what you do is you go to your g and you look at their x's. 8, 5, 10, 9. Okay, now I'm going to show the work here for this one. It's a little, I don't want to say lengthy, or sorry, wrong letter, hold up. G of 8, G of 5, G of 10, G of 9. Okay. So you go to your g function, you take the x's, and you put them in parentheses like that, because that's what x is, right? When you do g of x, you're looking for the x's. Make sense? Okay. Now, if the x's are the x, g of x would be the y's, yes? Okay. If x, in the set, in a notation, if x is your domains, f of x is your y's, g of x is your y's, right? What we just said? So g of 8, if 8's the x, its y is what? 15. Okay? Everybody see that? Up here in the order pair? So g of 8 is 15. G of 5 is what? 1. What's g of 10? 14. What's g of 9? 0. Okay? So that's this part. Okay? Now, do f of all those. So now go f of 15. So now go through your f function. So f of 15 is what? 11. Okay. F of 1 is what? 8. F of 14 is 9. And g of 9, or f of 0, sorry, is 13. Okay? From your f's. F is, what was that? I don't know. F of 15 is 11, just like you did the g's, right? F of 1 is 8. F of 14 is 9. F of 0 is 13.
Will it always be like matched like that?
Not always. Okay? Not always.
And if they're not matched, then it's...
We'll talk about that in just a second. Okay? Now, that's not fully your answer because you want the composition of it, and the composition of it is the number, in ordered pairs again, the number you start with, then the number you end with. Okay? So the first one, we started with an x of 8, you end with what? Top row. 11 as a new ordered pair. Okay? See how you're making like new ordered pairs now? So we started with 5, ended with 8. Started with 10, ended with, that was not a 10. Started with 9, ended with 13. That's your new function. You do g of 9 up here, which is 0, right? And then you do f of 0, which is 13. Use g's first, f second, because you're going inside out.
So, then where do you
Okay, so now we start with f. So f of 1, f of 0, f of 15, f of 14. Okay, now you'll always be able to at least get midway, right? F of 1 goes to 8, f of 0 goes to 13, f of 15 goes to 11, f of 14 goes to 9. All right, now if you want, you can start there as soon as this makes sense to you, okay? That's fine, I don't care. But now you need to start doing what? We have our f values, now we need to put them through what?
G.
G. So now you got to take G of all these guys. Okay, working inside, out. Okay, so same way, G of 8, so you go to your G of 8 is 15, okay? G of 13, what's that?
There isn't one.
There isn't one. G of 11, what's that?
There isn't one.
Isn't one. G of 9, what's that? 0. Okay, so the only two you can write now that's in your composition is 115 and 14, 0. That's it. Okay, come on.
Like say number 9, there's 2 9s up top.
No. That you had to pick and choose which one? No. There should never be repeating x's. There can be repeating y's, but not repeating x's. Okay? That you'd have to like take a guess on which one I want, right? Is what you're thinking? Yeah, shouldn't have to do that. All right. Now, if you went down and tried to make this and you went on all four, your function is undefined. That's the part where it says if they exist. If they all go, if you look at them all and you go it doesn't exist. But if you get one that works, that one is then your answer. Okay? Does that make sense? Okay. All right, so next type. You're going to be having 3 types of questions, okay? These are easier, I bet. Lucky for you. These are already. Now you're, instead of finding all your numbers or all the numbers of a set, we're only going to find specific ones. Okay? So, you still work inside out. That doesn't change. So we're going to do g of negative 2 first. All right, we're given 2 functions. First one being f of x equals 2x minus 5. Second one being g of x equals 4x. So basically it's 2 function evaluations. So you put negative 2 into the x for g. So g of negative 2 is 4 times negative 2. That gives you what? Negative 8. Okay. So this part here is negative 8. Everybody see that? Now put that in for f. So f of negative 8. Just like last time, except instead of looking at the number in the ordered pairs, now you're actually doing operations to it to get those numbers. Okay, see the difference? But you're still putting in your new y to turn into x. See that, how you're going inside out, working it backwards? Yes? Okay. So we got 2 times negative 8 minus 5. Negative 16 minus 5 to give you your final answer of negative 21. You want that final answer on this type. Okay? The negative 8's like your pivot point. That's like your middle part where you swing from one function to the next, though. So you definitely need to find it, but I only need to see that last number boxed. All right, makes sense? Questions so far? And just look at the problem. You know, the order of the letters dictate how your problem goes. So instead of this time starting with G, now we're going to start with F. Okay, so we're going to do F of 7 first. Should probably change color. Okay, so 2 times 7 minus 5. 14 minus 5 will give you 9. And then now put that into your next letter. So G of 9. Okay, last one, f of 6. How do you do that?
Plug it in twice.
Plug it in twice. Yeah, just plug it into 6. Just plug it into f twice. All right. So do f of 6 one time, which gives you 6 times 2, which is 12. I'm going to shortcut this one. Minus 5, which is 7. All right. Do f of 7. Do 14 minus 5. All right, last type of way they're going to be coming at you. For each pair of functions, find f of g of x and g of f of x if they exist. Okay? Chances are here they exist. Okay? Very good chances they exist. Okay? There's a very small chance of them not existing. So you really don't have to worry about the if they exist part. Now, like I said, I like this notation that they give it to you. It's the mathematically correct way. It's also the, to you guys, more useless way. I would always switch these to this. F of g of x, g of f of x. Okay? So, let's do f of g of x first, I guess, since it is first. So f g of x. Nothing changes as far as your process goes. That's the best part, okay? Now, if this was a number, what would we do? Plug it into g. It's not a number. It's a variable. So take that variable and plug it into the g. So plug in x for x, you get 4x. Fascinating. So you replace, it's almost like substitution, you replace this with what it equals, which is 4x. Okay, see that?
And then you plug that.
Everybody good? Okay. Now, Morford, what do you do next?
You plug it into
Now you plug that 4x that you've got from g into that x right there. Everybody see my two little dots? So 2 parentheses 4x minus 5. Because you were replacing the x, okay? You replace the x. You don't put it next to the x. You replace it. Everybody understand my emphasis here?
Yes.
Fantastic. What's your only thing you got to do? Multiply. Yeah, 2 times 4. The end. Make sense? Whoops. Okay, let's go the other way. No, it won't. Because you're plugging a different function into the other way. See that? Okay. Same steps. G of f of x. What's f of x this time? Or not this time, but still. 2x minus 5. So now you're taking 2x minus 5 and you're plugging it into g. Okay, see the difference? You always start these inside out. So when you do f of g of x, you take g of x and plug it into f. When you're doing g of f of x, you take f of x, plug it into g. Inside out, people. Inside out. Okay? So now you put g, or 2x minus 5 into g, which means 4 parentheses, 2x minus 5. Only thing you got to do is distribute. It's good. 8x minus 20. Will they always be this close? No. Okay? It depends on how complicated the functions you run into as to how close they get. These are two pretty simple ones, so they do end up being fairly close to each other, but still different, okay? So you got to get that differences. Okay? Questions so far? Still? Good? Okay, you got last two. These are for you. Prove to me you know what you're doing. You plug in x minus 6 into what?
G.
No,
Oh no, F.
into f, okay? Into f's x. Now, what is happening to f's x in the original?
Oh, yeah, 4.
F's x is being what? No. What is it being? It's being squared. Now, if you were just putting in an x or just putting in a 2, that'd be no big deal. But what are you putting in?
Square.
No. What are you putting in? You're putting in a
Binomial.
binomial. X minus 6. That binomial needs to be squared, and then don't forget about this plus 2. And then this guy right here needs to be what? Foiled. Not squared. That's how you guys got this x squared plus 38 answer.
Yeah.
Okay? Because you don't square the binomial right. Foil that binomial. I will hammer you on these because it's high time we learn how to square a binomial. Okay? You will have a lot of these. Be ready for it. So you foil that binomial out. X squared minus 12x plus 36. Still don't forget about the plus 2 to get your like terms. X.
Oh, that's what I said.
I know.
Oh, okay. You didn't want to give the answer one.
Okay.
Okay.
What a day.
X squared minus 12x plus 38. Your other way, not as hard. All right, g of f of x. F of x is x squared plus 2. So now you replace that x and g with the x squared plus 2. So x squared plus 2 minus 6, giving you x squared minus 4. Now, you don't have to factor that, okay? That does factor. You do not have to factor that unless the problem, like you're doing a problem where you need to do it for some reason. I don't know an instance for you guys where that will come up. Okay, so even though it does factor, even if this would factor over here, okay? This one obviously doesn't, but in case it did, you don't need to factor these unless I tell you, and I don't know why I would tell you, okay?
Oh, yeah.
All right, page 325, 1 through 14.
Panera for